Students were given this question: find the differential equation of the family of all ellipses having foci on the x-axis and center at the origin. So the required equation of the ellipse or the family of ellipses, you can use the word family of ellipses with foci on x-axis and center at the origin will be of the form x squared over a squared positive y squared over b squared is equal to 1, where a is greater than b. So this is a very important step along with the formula. Okay, so after you have written this, what we are going to do is we are going to be differentiating. We are going to take this as 1 and then we will write differentiating 1 with respect to. WRT stands for with respect to. Okay, writing down with respect to x. So differentiating 1 with respect to x, we get. So what do we get? Differential of x squared is going to be 2x divided by a squared. Differential of y squared is going to be 2 times y times dy over dx. Differential of 1 will give us 0. Now what I'm going to do is I'm going to differentiate this, differentiating with respect to x again. So this differential, this is going to be, now 2 over a squared is a constant, so differential of x would give us 1. Positive 2 over b squared is a constant, we have to differentiate y into dy over dx. So applying UV formula, I hope you know UV formula is u times v dash plus v times u dash. So that is the formula we would be using. It's also called as a product rule. So y times differentiating dy over dx will give us d squared y over dx squared. Positive differential of y would give us dy over dx times, there is already a dy over dx. Okay, this is equal to 0. Now rewriting this would give us 2 over a squared positive 2 over b squared of y times d squared y over dx squared positive dy over dx raised to the power 2 is equal to 0. Now dividing by 2 both sides, we get, so what do we get? Clearly the 2's that you see will be vanished, and that would give you 1 over a squared positive 1 over b squared times y times d squared y over dx squared positive dy over dx raised to the power 2 is equal to 0. Now what I'm going to do is I'm going to move this entire quantity onto the right side. Now when I do that, I would get 1 over a squared is equal to negative 1 over b squared times y times d squared y over dx squared positive dy over dx raised to the power 2. This is what I get. We got this differential. This is the first order differential which we obtained when we differentiated the ellipse equation with respect to x. So I'm going to take this as 1 dash, and this is what we have got for 1 over a squared. 1 over, after differentiating this above equation, again we got 1 over a squared to be equal to negative 1 over b squared times y times d squared y over dx squared positive dy over dx raised to the power 2. Now I'm going to take this as 2. Now this is an important statement. Using 2 in 1 dash, we get, you need to write the statement. So in the place of 1 over a squared, now this 1 dash can be rewritten as 2x times 1 over a squared positive 1 over b squared times 2 times y times dy over dx is equal to 0. So in place of 1 over a squared, I'm going to be substituting this. So this is going to be 2x of negative 1 over b squared times y times d squared y over dx squared positive dy over dx raised to the power 2. Okay, so this is what I have substituted, followed by positive 2 times y dy over dx is equal to 0. Of course, there is a b squared there. Now clearly we can remove the 2 out, so 2 can be cancelled. Now I can rewrite this as y over b squared with a negative sign d squared y over dx squared positive dy over dx, okay, times y squared, and there is also negative 1 over b squared, so let me try to squeeze it there with a negative sign. Okay, and positive y over b squared times dy over dx is equal to 0. So we got a negative 1 over b squared there. So let me just rewrite this as x times y negative 1 over b squared d squared y over dx squared. I'm taking x inside, but I'm retaining negative 1 over b squared as a constant, positive x times dy over dx raised to the power 2 positive y over b squared times dy over dx is equal to 0. Now multiplying by b squared both sides, we get, so what do we get? This b squared and this b squared, they get cancelled out when we do the multiplication. So that would give us negative xy d squared y over dx squared negative x times dy over dx the whole squared positive y times dy over dx is equal to 0. This is what we are getting. Now what we can do is, now I want to remove this negative sign, so what I would do is multiplying by negative 1 we get. So when you do that, the differential equation would become xy d squared y over dx squared positive x times dy over dx the whole squared negative y times dy over dx is equal to 0. So this is the required differential equation.